Hello everyone, welcome back to my YouTube channel. Today we are working on our chapter 11, which is shell scripting. So if you are new to this channel, welcome. This is getting started with Linux, and we are at our chapter 11, which talks about basics of shell scripting. Right, so we'll talk about why do you use shell scripting. We'll also kind of write, save, and execute some bash scripts. So till now we have been running commands one at a time, right? Which is not scalable. Imagine you need to run same command on 1,000 servers, 10,000 servers. It's impossible, right? There is a possibility of you missing something when you are running. Let's say you have 200 commands, you are running one command at a time. There is a good possibility you'll miss something and it will result in problems, right? That is one reason. Second is, um, you want your code to be, or your commands to be reproducible, right? You should be able to run on thousands of servers, we talked about, right? So that's where shell scripting comes into play. uh, on top of that, you want user to request, provide some inputs. You want to handle input in different variables. You want to loop over files. All that can be done using shell scripts. So this is kind of basic shell script we are looking. It won't be super deep, but we'll cover some basics that will help you get started. Right. So what is shell? Shell, we the prompt you see here, right? I'm running a command ls, for example. If I say lsla, you can see it gives some output, right? So shell is a command language interpreter. So you are passing a command, something is interpreting that command and executing and giving you the output. So that's what shell does. Okay, so yeah, when you run some commands, your interpreter, which is understanding those commands to produce output, that is called shell, right? So you want to run commands in same sequence, automating system tasks, creating small tools, right? Uh, so how do you do it? You can copy paste these things one at a time. For example, here, echo means it's gonna, like when we say echo, right, it is similar thing to going in an empty room and shouting your name. You'll hear your name again, right? So echo does the same thing. You run anything after echo in codes, you see that as it is printed on the screen, right? Then we were running some commands, for example, pwd. I just ran ls earlier, right? So it is giving you outputs. Before we start writing our first script, we need to understand something which is called shebang. So this shebang line you will see on most of the scripts. Almost every script that you will see written in bash, or scripts that run on Unix systems, most of them will have the shebang line. So this shebang line starts with a hash and exclamation sign, and then executable name. So this tells your script, when you run your script, this tells what is the interpreter to use to interpret all the commands that you are writing in a file. Let's assume you wrote 10 commands. If you don't write this, then there are, then there is a way to run the script, but you will have to every time write slash bin slash bash, for example, then name of the script, right? So that is one way of executing. But if you want to make it look like system utilities, for example, this pwd command, right? We are not saying like bin bash then pwd. We don't do that, right? So when you add this shebang, it makes your scripts kind of standalone, provided it is in your path, one thing, and it is executable. So what is another thing you need to understand? There is a variable called path. So this path variable makes your shell figure out if there are any commands in given directories. For example, user bin. You see there are so many commands, right? You can see so many commands listed inside that, right? So this path variable, this defines from where it'll pick up a command. Let's say if I say zip hyphen h, right? So it is able to figure out zip. So which zip, if I do this, you can see it figured out it is in user bin. So how it was able to figure out? With the help of path variable, right? So again, coming back to our scripts, so you define, when you define script, you define bin shebang. So the shebang line, we are saying all the commands written within the scripts are um, to be interpreted by bin bash, right? There will be cases where you will see people use env. So here is an example. I think I have given kind of one example here, right? This one, right? So the way it is written is user when env then bash. So it means if somebody's path has bash coming from a separate directory, for example, uh, in my case, if we say path, you can see it is coming from these locations. But when I say which bash, you can see it is coming from bin bash. If I have a, let's say, so we can say bash hyphen hyphen version, right? So it tells me 518. Imagine I had a newer version of bash binary placed in this directory, right? So the way path gets read is it starts from this side, left side. So if something is found here, it will stop here itself. Then next, then next, then next, right? That's how it goes, precedence from left, right? So imagine if I had a bash named file. Let's try. And if we say which bash, so you can see it is coming from user bin bash. What if I create one here? Let's try it again, right? So let's do bash and let's ask. Still didn't change anything. Why? Because this one is not executable. You don't see the permission, right? So ch mode, let's say plus x, right? Now let's see which bash. You can see what happened. From user bin bash, it became user local. So lsld, let's make sure we see the full path. This is where I created the file, and that is the file that you see here, right? So you can see it is 0 byte file. I don't need this file. I don't want to mess up my environment. But what am I trying to tell you with this example is, so when you have your variable defined like this, user bin env then bash, then it figures out from the path, dollar path. What it does in turn is it makes your scripts bit more portable, right? Less tied to a specific file system layout. So there are different Linux implementations there. They might have different directory structures, although it is becoming standard now, but still, in those cases, this might be a kind of bit more preferred approach to create a script. And this entire line will be the first line in your script, and this is called shebang line, right? So how do we create a, let's get started. How do we create our first script? For example, I'm creating a script. I created vim or vi, anything works, right? You are creating a script. What are we doing? We are getting started with the shebang line. This one is a comment. Anything starts with the hash is comment, except this one. This is a special use case. right? Okay, let's do this. But if I want to execute it, right, it won't work. So if you don't know, I had to press colon, and then you can say X or you can say WQ, right? And sometimes we do this because the file is not writable by default, right? So I did this, I'm out, and then I'm adding permissions. So lsl hello, and you can see it is now executable, right? Sorry, executable by others. Basically what I'm doing is giving executable access to everyone. So if I say hello.sh, you can see it gives me some output, right? So uh, there are kind of different ways of executing it. So if I say chmod -x, and let's see the permissions, you can see it is read only. So if I try to run it like this, it will say permission denied. I have something similar kind of shown here. You'll see permission denied, right? So how else you can execute it? You can manually execute it like this, right? So this bash is basically calling this. So bin bash hello.sh, and you can see, right? So to make it more kind of portable, we added a interpreter inside that, and then give it execute permission. And now we don't need to tell that bin bash will execute it. Why? Because we have that shebang line in the beginning. Okay. All right. So another interesting thing, if you are writing similar scripts, something that I have not written in the code, but for example, you can do bash -x. If I say, now I try to run it, I did -x. You -x is basically, it is this -x that I just added. It lets you debug your script, right? So I just removed it. If I run it now, it shows the output. Otherwise, you can see it was showing you what command it is running, then the command runs, and you can see the output, right? So this is how it works. So we know what is shebang, we know what is, why people use that env style of writing it, this one here, right? We know permissions, we know path, we know it always goes from left to right. And if you have a executable in the path earlier, that takes the precedence. We created one script, and now let's talk about defining variables. So variable, what is a variable, right? Variable is a name, basically anything. Variable could be anything that holds some value. Why it is variable? Because it can be changed, right? So that's why it is called variable. So let's create a small script. Okay, so you can see this is shebang. This is just a comment. It's a good practice to add comments, and then you can add even version information and all that. But here we are defining a variable. Variable gets a value assigned with equal to, and within the quotes whatever you write is becomes the value that we hold inside this name. Okay, so how do we see the value? How do we retrieve the value? We could call it with a dollar sign. Here echo command is writing hello, and then with dollar sign we are saying give us the value of name, and inside the name you can see it says TKS learners, right? So I'm exiting out chmod greeter plus x greeter and greeter.sh. You can see what it did, right? So I can do another way of executing bash -x, and you can see it defined a variable, it did echo, and then finally this is the output, right? So that's another way of kind of debugging. If you don't want to add this -x inside the script, you could run it outside. Right. So now we know variable. There is something special in Bash which is called arguments. So when you run a script, you don't want to kind of hard code everything inside, right? Sometimes you want users to provide input. Sometimes you want these arguments to come on the fly, right? So for that we'll write another script. So there are arguments are number like $1, $2, $3, and they go all the way to dollar at the rate, right? So if you want to learn more about this, these arguments and all, right? So I have this a link here, and this basically you go in this bash manual, I would say. This is much better option. So if you go in bash manual, there is a section called special parameters. Read that section, like what does dollar star means, right? It expands the positional parameter. What does dollar at the rate expand the positional parameter starting from the one, right? Starting from the one. So it gives you some details, right? So like one, two, so on and so forth, right? So I would say if you get time, read through this special parameters. You're going to use it repeatedly in your scripts, right? So let's get back to our script, and let's write our first script. So $0. What is $0? $0 is name of your script itself. So let's see what name we are writing it as. We are writing it as greet user, and excuse me, excuse me. All right, chmod plus x greet user dot sh. So greet user dot sh. You can see I just ran it. Then it says script name is greet user dot sh. Right. So how do I see it? Right. Bash minus x, and now you can see echo you passed 0 arguments, script name is this, right? So it is picking values. Then it says hello because we are not passing any argument. That's a test. You can see you passed 1 argument, test, hello test. So if we don't write this bash x, you can see script name, you passed 1 argument and test. Now let's get back. So it says script name $0. $0 is the name of the script itself, the one we are executing, right? So let's say pwd. So if I execute it like this, you can see script name, it is giving the full path of the script, right? So then it says you passed $hash arguments. So $hash is 1. Okay. Test command testing one at a time. Let's see what happens. Say you passed 7 arguments. You see, we passed 7 arguments, right? What if we put it inside quotes? Now this gets treated as 1 argument. You can see it shows as one. Here it was only first. Okay, so quotes helps you with that. Right. Now let's get back. All right, so I have some examples, similar story, the things I'm trying to show. You know, you're passing 1 argument and, again running the script with the 1 argument, but this time we are writing 3, but with quotes, but it gets treated as 1 argument, right? Then another interesting thing, you can get the exit code for commands. So why it is important? Because you want to know whether the command succeeded or failed, right? So if a command succeeds or command runs successfully without error, then you will get a exit code of 0 with dollar question mark. So dollar question mark is another special variable, right? So let's see by running it for something that doesn't exist, what do you think will be the exit status code? If we run it, now you can see exit status code 2. If I run it again, what will happen? Exit code will come 0. Why did it change? Because this question mark, dollar question mark, was exit code for this command that failed or did not work successfully. Now when I run it again, this is a question mark or output of exit status of echo command that I ran here. We can see that command ran successfully and it provided us the right output, right? Because this command ran successfully, next time you try running this, it is coming as 0. So this is, it doesn't mean you can keep using it, right? You can use it, but right after that particular command. So as soon as that command finishes, you want to know the exit status, this is what you use. Okay. All right. So let's put it in practice and see within a script too, right? So we created a script called backup, right? Check backup, chmod plus x. Now we run it. So yeah, another thing, I am doing this dot slash check backup. This dot slash tells my interpreter, which is bash, that I want to run command from current directory. So when you run lsl, right, lsltr, let's say, or lsla, sorry, you see two directories. One is dot, another is dot dot. So dot is your current directory, dot dot is the parent directory. Okay, this is hidden directory, special case. So when I run command with the dot slash, I'm saying my interpreter that I have a script inside my current directory. What if I don't want to do this? I can do this, for example, cp minus p, let's say check backup inside this directory. Okay, let's remove it from here. Now if we see lsl, there is no check backup, but it is inside this directory. But because it is in my path, what I can do is I can simply type check backup.sh. You can see it ran. So if I say which, you can see it is coming from here, lsld. If I want to see the full path, you can see it is coming from there, right? So uh, if your script is in current directory, you do this like this, right? If it is in your path, you don't need to do that dot slash. You can just run the script, right? Anyways, my intention was not to keep using it from there. I don't want to kind of put it in my path. But if I moved it out of that place, and if I try to run it, it says it doesn't exist. But if I run it with the dot slash, you can see it ran, right? Echo dollar question mark, again checking the exit code. That failed by because there is no such directory where backups, right? All right, so we can, same thing I'm doing it here, right? It says exit with 1, right? So now we know some special variables. We know this dollar question mark is the exit code. We know $1 is first argument, $2 is second argument, right? Dollar at the rate is all the arguments, right? So we did see some special use cases, like special parameters that we saw, right? So we learned all that. Now let's see, what if we want to do a if statement? For example, we want to do some logic, right? We want to say if directory exists, place a file. If doesn't exist, create directory, then place a file, like that, right? to make if successful, there are some built-in commands or built-in options. We we call them test. So test is a utility. I just ran it, and if I say echo dollar question mark, you can see it failed. Why? Because there is test hyphen f, because that doesn't exist. So in my home directory I have this file, right? So if I look at now, test resulted in success, right? So this is one of the command called built-in. If I run built-in help, there is, there are some let's see, echo, no, bash hyphen hyphen help. Maybe it is in the map. Yeah, so bash c built in. No, if it can let me do that. Mm, I don't have man pages on this machine, if I recall correctly. Built-in help. So built-in, let's say test, built-in help test. Uh, so all right, so there is a utility called compgen. If you run this, basically compgen help you see all the built-ins. These are some of the built-ins that are embedded inside your shell itself, right? So that's why I was talking about this test. You can, there is a command called enable uh, and disable, if I'm not wrong. Yeah, no, I think it is enable and hyphen hyphen help. You can enable hyphen a list all enabled. By default it is enabled, test is enabled, right? Then you can disable, um, for example, enable n test, enable a, let's see, where is the, yeah, so you can see it went like this. So we can do it, enable test and enable a, and you can see, right? So that disables. So what I'm trying to say is, when you are running commands like this, uh, like for example you want to test things, there are a few built-in features available in shell that help you to test things. For example, you want to test a file, all you need to do is hyphen f. So this hyphen f, there is something missing. We are not writing test here in front of hyphen f. Okay, so this is test hidden or built-in calling directly with hyphen f. So what we are saying is, our first argument, whatever we run, we are running a script, whatever we are providing as first argument, check if it is a file. True if file exists and it's a regular file. D if it is a directory, D for directory, right? Similar test can be done on directory. X can be done on a file and it need to be executable, right? So that's the kind of example. That's why I spend so much time on test, right? So let's create this file, check file.sh, and let's put our code in it, and yeah, and chmod plus x check file. let's say check file.sh, and um, let's give it a greet user.sh, right? It says file exists. Test, let's say there is no such file in my home directory. A file that does not exist. You can see that thing definitely doesn't exist. But if I say etc password, it works. If I don't provide anything, then it says that thing doesn't exist because we are not even providing argument to it, right? So this is how you check. So this if statement, it starts with the brackets and then a semicolon, and in the end it needs a keyword. That keyword is then. So if this test if this test is successful, then show this output. Else, if this test is not successful, show this output. So that is what it is doing, right? So if we do like this, bash hyphen x, check file, if I run it like this, right? So it says file empty because I did not supply any argument to it. It is running a test, then it says it doesn't exist because it went to else statement, because this test proven to be false. Now let's give it a file that actually exists. So we gave it a file. It said check if this file exists. Yes, that file exists. So you can see exists comes here, right? So as soon as test is successful, we see output from this section. If test fails, we see output from here, right? So this gives you some logic around, when you are trying to kind of validate some conditions. So you can do more than one condition, right? You did if condition, if it is successful, run this. Elif, then another else and if condition, another condition, if it is successful, run this. If that also is unsuccessful, go to this one. If any of these meets, as soon as first one meets, it gets out. If second one meets, it gets out. The otherwise finally it comes out at else condition, right? That's how it works. Now let's see, run this one, right? Which says number, whether number is greater than 10 or less than 10, right? Vi number.sh, let's say, right? Give it any name. So chmod plus x number.sh number dot. If I run it with, let's say 11, it says it is greater. If I say 10, it says number is 10 or less, right? If I say 3, it says number is 10 or less, right? How? There is something called gt. Gt is greater than. So you can compare the numbers with the help of eq. Eq is equivalent, equal to, not equal to, less than, greater than, and so on, right? So you can see how we are doing it here in this script. Similarly, this was if statement, but what if you want to run it for multiple times, right? This is something you'll use it very frequently in your daily life, right? So let's say for x in 1 to 10, do echo dollar $x, done. You can see what it did. It ran this echo command 10 times. Echo, let's say Hardeep. You can see it ran 10 times. It printed my name 10 times. This thing is expanding, or people sometimes do seq 1 to 10, right? So basically this expands to how many times you want to run it. Anyways, so what is happening in this? What is x? So it is better here. You look at for item in 1 to 3, echo item done. So it is taking one item at a time, rotating it through, and then printing. So let's copy paste that thing, right? So you can see for item in 1 to 3 echo item done. So what is happening? It is assigning a value to this thing. So if I say echo dollar item, you can see it says 3. Why? Because that was the last value. So all these things are becoming variable values one at a time, and that is how this for loop is able to print 1 to 3. And similarly, this is how it was able to print my name 10 times. Okay. uh, there are some other good examples where you can do real life use case tests. For example, you are in a big network, you want to test whether IPs are available or pingable or not. So what we are doing is, for host in, you can see this is one argument, this is second argument, this is third argument. They are separated by space. Okay. Then we are saying pinging dollar host. Okay, so it will print pinging 111.888 localhost. Then what it is running? It is running ping command count one time, and then what is it pinging? It is pinging value of dollar host. Dollar host value will be 111.888 or localhost, right? This is called redirection. We are sending output directly to dev null. This too is error out. When you run a command, that command fails, you see output on screen. So that output is number 2, that has a file descriptor number 2. And we are also doing greater than and 1. So this greater than and 1, what it does is, even output and error, both of them are thrown inside dev null. You are not seeing any output. What we are looking after is exit. If exit of previous command, ping command, equal to 0, host is reachable. If not equal to 0, not reachable, right? That is the idea. Chmod plus x ping host. Let's see ping host. You can see what it did. It did ping and says reachable, ping reachable, right? So let's take a look at this. If I, let's say I did y, y, and p and commented that line, I want to show you what it does. Basically, if I run it like this, you can see output is all jumbled up. It is throwing standard out and error on screen. To make it look a bit more professional, we are throwing the output to dev null. It's a special uh, device, corrector device, that you know that basically destroys everything. You can see it starts with C, right? It's a special corrector device. Anything thrown on that becomes null. So we are throwing output error, standard error, and standard out inside that. And that's how when we run ping, what we see is very clean output, right? So by using output redirection, you are able to produce nice results. We are here validating whether that script ran successfully or not. If statement is coming together, you can see how logically it is letting us do things. You can see we did for loop. Inside that for loop, we ran if statement, and then finally for loop ended here at done, right? So this is how humans also think about things, right? We um, we we do one action at a time, but we kind of sequence them properly, right? If you were doing this manually, you would be running ping and then writing in a file, yes, it is reachable, not reachable, right? So shell scripts make it more repeatable. That's about it. Then we have something called while loop. Similar to for loop, we have while loop. If you run this, hold on, I didn't have a file, I'm gonna give it a file, right? So what it is doing is, while read line. Okay, so this line is a kind of variable, right? So we are asking it to read lines, and then we are kind of incrementing number one at a time. Echo line number, we are printing the number, then line, and what we are reading is this. So this is standard input redirection. This less than symbol is standard input redirection. So I'm sending a file. I'm saying read this file and give me the output. Okay, that's the idea. We are starting with num0, making sure our counter starts at 0, right? So that is how you can produce kind of nice lines, right? And then let's write another file, count lines.sh. Let's put it in a script. So if we put this in a script, similar thing what we are doing is we are looking for first argument. In this case I was passing it like this and with the help of input redirection. But in the script, instead of doing input redirection, I want to provide a argument, right? If then again starting from count 0, this count does nothing special. It just gives me the kind of counter, right, in the end. So let's see. Let's try running this. I have listed many things here, but let's do one at a time. uh, let's see if etc password has how many lines. It has 28 non-empty lines, right? What are we looking at? We are looking at if line is hyphen n, again the test statement, right? Hyphen n if it doesn't exist or it doesn't, variable doesn't have value, right? Okay, hello.sh, it says there are three only, right? So now if we look at greeter.sh, right, so it says greeter.sh has 4 lines. But if we run a command called wcl that says greeter.sh has 5 lines, can we see if it has 5 lines? So cat hyphen n gives you a number in the beginning of line. So you can see there is a simple line that we omitted or left empty, right? So if I say cat, you can see there is a line empty. That's why it has 5 lines. But our script, when we run it on greeter.sh, right? So count lines greeter.sh, you can see it says there are 4 non-empty lines, right? So this is how you are able to get rid of clutter, right? Next one, it basically, how do you ask a user for input, right? So this is the script. I named it as askme.sh. This hyphen e is to expand, and expand hyphen n is for a new line. That's a special character, right? So read is asking user to provide input, and that input gets stored in a variable named name, and then we are calling the value of that variable inside this file. So let's see, chmod plus x ask name and ask name.sh. You can see, okay, I did not give it a argument. I should not have provided here, but anyways, let's say, right, it says, so there is a way you could say $1 and it will not even ask you. We can do it that way also, right? But anyways, that is one idea. Then you could also basically pipe through a variable and send it to the script, right? So because we are sending this cube learner in codes, it gets stored inside this variable read name, and that's how we see value of it, right? So if I say $name, you won't see anything. Why? Because it happened all within this file. Okay, we did not use something called export. If we had written a command, the command says export space name, that will make name available throughout my environment, right? It's kind of making it global. Here this, all your variables are staying local to the environment or where you are executing. I've given some best practices, I have given some homework. I would say please go through it. uh, try to write these things yourself. Again, I try to keep it as simple as I can. I know there were so many things I introduced. uh, for a beginner it might sound overwhelming, but this is what will help you get started with the scripting on Linux. This chapter builds on previous 10 chapters, so I would say please go through the series from 1 to 10 so that you are able to better run commands and you know how to find help just in case you are stuck. With that, I'll stop recording. Thank you. And if you have any questions, comments, please comment on my YouTube or on my LinkedIn. Thank you, everyone. Have a good one. Happy learning. Bye.